Namaskar, hello and welcome to NCERT's live phone-in program. This is our special program, webinar on ICT tools, and today we are going to talk about the topic visualizing maths using KmPlot. Well, what is KmPlot? KmPlot is an open resource, educational resource similar to GeoGebra. That supports different mathematical functions, derivative and integral of the functions. And rest about KmPlot we'll talk about with our expert. If you have any doubts, any queries regarding KmPlot or maybe GeoGebra, if you want to know anything about this software and how does it work, what all it has in store for us, for all the students out there, then please contact us on our phone numbers. We have got two toll-free numbers, 1800-112199 and 1800-111-265. You can also email us your queries on ciet.kishoremanch@gmail.com. You're watching us live on our YouTube channel, NCERT Official. You can write your questions in the live chat box of the same channel. You're watching us live on various channels as well, like SWAYAM Prabha's channel number 31, Kishore Manch. On Airtel, you can watch us on channel number 440. On VmVideocon, the channel number is 477. And if you want to see all those channels which have been done earlier and you have missed it, then please download the app Kishore Manch for all those sessions. They are all available there. Let's meet our expert for this particular session. We have with us Mr. Ramesh Baduni. Welcome, sir.
Good afternoon, ma'am. Good afternoon. Good afternoon, all viewers.
Good afternoon, sir. Sir is a national ICT awardee, and I'm sure he has got a lot of information for you and for me as well. So let's begin with this discussion. Sir, so KmPlot, what exactly is this software all about, and what all can you inform us, the students, the viewers, about this software?
Thank you, ma'am. This is Ramesh Baduni. I'm National Awardee 2012. I'm lecturer for physics, and presently I am working in GIC Misraspati, Dehradun, Uttarakhand. Today I'm talking about visualizing mathematics or physics or any sciences where we are using different kind of function, and I will use an application KmPlot here today.
Okay.
So let's start. First, I will talk about what actually KmPlot is and who can use this application and why it is that much useful.
Okay.
This KmPlot is a mathematical function plotter, and it is available at KDE desktop. It helps us to plot different functions simultaneously. It helps us also to combine different function with a new function. It is very much helpful for the teachers, student, or even for the graduate scholars, or even anybody who's in a science and mathematics, or even in statistics anywhere in the world. It is very much close, as you told, like GeoGebra applet or like Graph Monkey. It helps us to trace graph for the different functions. It also is very much helpful in finding the integrals and derivative of different function. It gives us animated view of the graphics, and it can help us to change the colors as per our need. We can have a scalable vector responses, and we can zoom out, zoom in, animate the graphs. Even we can have a different kind of graphs like Cartesian, parametric, polar, implicit, differential or integral function. It also provides us simple mathematical tools like finding the maxima and minima of a curve or graph. It also help us to export our output in different format like PNG, BMP, SVG or JPEG, like that we can do. This KDE educational community is especially creating free software, and a number of softwares are there by this community. Like we do have Calcium, Canagram, Marble, and today what I am talking like KmPlot.
Yeah.
So that first we will talk about how we can use it, and then now I will talk about its feature also. But first, let's talk about what are the features and how we will install it in our desktop. So
Okay.
suppose right now I am showing you how to install KmPlot using Linux distribution. And for example, we do have a different kind of OS operating system, Linux, Debian, even CentOS. But right now I am using here Ubuntu, and I will show you how to install it in Ubuntu. So
Okay.
let's go here, and I will try to show you how to install it here. First, what we will do, we will go to the just wait, I will show you how to install it. I am visible to you, ma'am?
Yes, sir, you are.
Okay, okay. So first, what I will do, I am going to Ubuntu store,
Okay.
and here I will search KmPlot, right?
Okay.
So suppose I will search KmPlot here, it will look like this. It is already installed in my system. So that way you have to search through the Ubuntu store and you have to install it. So it's already installed. So it's not very difficult task to install. Easily it will be installed. So when it will be installed, then straight you will have the application like this. If you search it here, now it's installed, you can search it here like this, KmPlot. So it's already appearing here. So if you can see it, you can say me in between yes, so that I will have that alarm, yes it is visible or
Sure,
not.
sir.
It's visible.
Yes, sir.
Okay.
I can see the search bar where you have written KmPlot.
Okay, okay. So this KmPlot, now I will go straight to the KmPlot.
Okay.
So this is the interface of KmPlot, where I'm going to show you about the graphs or different function. So
Okay.
there are two window. One is at left side and another one is at right side, where you are seeing the different grids, or this part is called graphic window, and this is our input side, where we have to create different kind of functions whatever we want to. So first I will tell you about a little about its menu, what it looks like and what it do for us.
Okay.
Say it is its file menu, where we can create a new file, we can open our old file, or we can see the recent one, we can save as and print preview, and even we can export. So I'm just trying to tell you about save and export. Whatever output, it will be saved from here, and save as like this. We will save. So it's not a very difficult task. Everybody knows how to save. So whenever we will create the function, I will tell you in between. Same thing, export. So there are number of options we have to export it like this. I will show you like this window, BMP image, JPEG, even PBM, so many like SVG. So
Okay.
these are the output format for us when we will have a plot. So this way we can save the plot and we can export as well. Now this view window, what it help us to do, it can help us to see the full screen mode. It also help us for zoom in, zoom out,
Okay.
even to adjust the trigonometrical function. We can reset our window, we can reset the coordinate system, means whatever the coordinate we want to set for horizontal axis, for vertical axis, and even we can customize the grid size, grid space like this. Suppose I am writing here say 2, and if I will write here apply, so the size will change, right?
Okay.
And or you can keep it as defaults. It's better in the learning stage, we can keep it at a default mode.
Okay.
Now same thing, we do have again here a tool window, where we can have a calculator. This calculator is also very much used. Just a minute. Okay, this calculator is a very helpful for us in between. We want to input our expression, so we can write from here also. We can edit our constant, whatever used to plot the function. Even we can insert constant, we can insert function, like different function we do have here. It is already there, all kind of functions: sine, cosine, chord, log, maxima, minima, square root, tangent, even hyperbolic function, all are there. So we can use all these during our graph plotation. Now even I can show you how can we fix maxima and minima. Here we can change the maxima or minima for any graph. Same thing we can do with minima. Even we can find out the area, maximum area of the graph covered, or minimum area, that we can find out. So a lot of things we can do using this tool. Even we can change our toolbar. We can configure plot like this, how the diagram or graph will appear. You can change even lines of the grid line, or even you can change its nature. Like suppose I want to polar grid, so if you will apply it, it will looks like it's visible or not?
Yes, sir.
Okay. Even we can increase the axis width also. We can even change the thickness of the line. We can change color also as per our need. But if you want to means make it appealing for the student, it helps us. Otherwise, you can keep it as in a default mode. Whatever we will do, that we can do here. So suppose first I will change the graphics first. Because I changed it, so I have to set it lines. Okay. Okay. Now same thing, one more is help option is there. There is a handbook which is very much helpful for the new user. They can learn from here and they can start. Even online you can see all kind of help is available there. Tutorials are there, manuals are there, so anybody can use all these things during their creation, right?
Right.
So let's start. Before this, anybody want to ask anything, or shall I start with creation?
So please start with the creation, and we'll take up the question answers in the end.
Okay, no problem. So let's start with different functions. So here in left side we do have a create window. And in the create window, we have a different function like Cartesian, parametric, polar, implicit, and differential plot. So I will take one by one, and other can also, if they have a system in their hand, they may try with me, or even they can try afterwards. So it's very easy and conventional for creating a different kind of function. So initially, let's start with Cartesian plot. So in the Cartesian plot, here you can see in the left side this window, we do have a function like it is written f of x is equal to 0. So if I will input any algebraic equation or any Cartesian function here, say I am writing here, for example, x square, so how it will show the graph. So this you can see, this is a parabola. This is the equation of parabola, which I had given in input. I just typed here x square, and then we have the plot for the x square. So in graphic window you can see the color also. This is the violet color for this graph. You can change it also.
Purplish.
And even you can change thickness, or if you want to see it more appealing, you can increase the width. Okay,
can you do that, sir? Can you?
Yes, yes, I'm doing. Even you can show its name. Okay, so it's little bit more bright, I think so.
Yes, sir.
I increase thickness. Even you can change color if you want. Like if it is not visible, I will make it red, so it will be red now. Well, right?
Right, sir.
Now this is a parabola. You can show it easily. Now same thing, suppose you want to create another function. So this will be name as like this gx, right? Then you can put input any value. Say I am writing here sine of x.
Right.
sine of x. So this is the curve for sine x. Okay.
Okay.
So I can even change its color if it is not visible, then I will change color also. Now
So
it's
more than the
green.
color, please increase its
Okay,
thickness if
okay, okay,
possible.
okay, okay. Just I will increase as well the thickness.
Yeah, because it's very light, and
Yes.
the block where
Actually,
you are typing to, it's very
uh,
small. So please,
this is the software issue, ma'am. Actually,
okay.
even I took my desktop larger screen.
No problem,
Uh,
sir. So
like
talk while you're writing. That's what I'm
okay,
saying.
okay, yes, yes, yes.
Yeah.
So even this is a sine function which is in a green color, and you can see the sinusoidal wave how it moves. Its behavior you can see.
Right.
So whenever we are teaching in class, when we are just writing on a board about sine x, the student are not able to visualize the nature of the function. So
Okay.
here he or she can see the nature of the function. Similarly, if I am creating another Cartesian plot, say I'm writing here one more command, say cos of x. Okay.
Right.
So here I can write, suppose you will write any wrong, it will not reflect. Here it is showing syntax error. Okay. So that is also there. You have to be very careful when you are writing the command. So we do have now, this is a cos curve. I can make its thickness little bit more up.
Yeah. So it's again wave-like.
Yes, yes. It's just means you can say reciprocal of sine function,
Right.
because if sine start with 0, then cos start with 1. So you can see the difference. If the green is at 0, that time your blue one is at 1. So that difference you can see through the graph in sine or cos wave, right?
Right.
So these are the three functions. Even right now, I will not talk more about mathematics of these functions. I will
Okay.
just talk about this tool and how it is useful in showing the function, because
Okay.
mathematics, again, it will be a different part. Right now we will talk about the tool also, more about the tool, right?
Right.
Suppose I want to join, or I want to combine two functions, so I can do that one also here. Suppose I have a now new function, and I want to combine, say, this function, the first one, parabola one, and suppose let's first I will hide one more function here. I'm just now showing you only sine and one parabola here,
Okay.
right? And let's how to combine it. Even we can change the name. For changing a name, you have to select the function, and then you have to write in front of f or the function name, say it is a parabola. I will write parabola. Okay, so that it will be easy to show you is parabola. Now you can see here it's on the graph parabola, it's showing you parabola.
Right.
Okay. Now suppose I want to do same thing with here with this function. So here you can display the name also of this function. You can have the name also for this function. Same way you have to do, because it's sine function. Suppose I wrote here, so it will be a sine function.
Okay.
Now I will show you how to combine these two functions. Say I am taking this I of x new function, and I will combine this parabola and sine x together, right?
Okay.
So what I have to do, I have to write this one, say parabola of x plus this gx. Okay, so enter. So now you can see this. I will just make it more thicker.
Yeah.
Say so. You can see here this orange color. You can see.
Yes, sir.
Okay, so this orange one is just, it is showing the combination of both function like parabola and sine. So you
Okay.
can see their meeting point here, where both are at meeting at one point. So this meeting point is showing these two combines here. So if I take my cross wire, this one at any point in the graph, say suppose I put it here. So you can see in the left side at the bottom, you do have a coordinate x and y, even you have root values, and what exactly the parabola equation is there. If I will shift it somewhere here, so you can see the root is changing and xy is changing. So that way you can fix the cross wire. Suppose I will fix it on the green curve, so you can see the value of x and y is changing in the left side at the bottom,
Okay.
right? So
Right.
means student can visualize how the coordinate geometry works, how coordinates are changing, and even how the sine or cosine or any curve roots can be determined, or by combining any two graph or function, what will be the result. So that way we can do with Cartesian plot. So if time will permit, I will do some more animation work later.
Sure, sir.
But right now I will show you how to even delete. Even you can select this window to hide or unhide the function, right? Or even you can delete one by one by selecting each function, whatever you want to delete, that you can delete from here. You have a delete option.
Okay.
Okay. Says is saying remove all, so you can remove. That is for combined function. So
Okay.
this way we can delete all. Now window is clear.
Yeah.
So it's just about the Cartesian function. Now
Okay.
suppose we want to create implicit function. Just I'm taking implicit. So what implicit means, there are two variables, say x and y.
Right.
So if I want to show the equation for like we do solve equations, simultaneous equations in classroom,
Yeah.
or if we do have some equation like circle, parabola, hyperbola, ellipse. So that kind of equation where x and y are useful, so we can plot the graphs for also. Suppose I do have a command here, x cube minus x plus 1, and I am writing the equation here. Sorry, I want to show the graph for it. So I will type here f of x y, uh, and I will close this parenthesis. So you can see the graph. Can you see? This is green line. I will make it a little bit bolder,
Yeah.
so it will be visualized.
We can see, but it's very light again.
Yeah. So now it's visualized, I think so.
Yes.
So
Much
suppose I am
better.
writing any quadratic equation or any equation where x and y two variable. So that way you can see how the graph looks like. This way you can do. Even suppose I want to change it. I want to write say any equation of a circle. Here say I am writing here. See, generally the equation of circle is given like this: x square x square plus y square is equal to say 9. Okay, so this is a circle, or I can show you little bit bold. It will all the time I have to do, I think so. Okay, so this is a equation of a circle, and this is a graph for the circle.
Okay.
Same thing you can do with this also. You can change it. Say you want a parabola, or you want a ellipse, so you can type equation of ellipse. Say x square. I'm audible?
Yes, sir. Totally.
Okay, so this say x square divided by say I am writing here 9 plus y square divided by say 16 is equal to 1. Okay, this is the
Okay.
equation of ellipse. So you can see here this is a ellipse. You can see the graphics is little bit means you are assuming it will be circle, but it is not a circle. I can show you with a different equation also.
Okay.
Right. Say I want one more equation here. I will change one more ellipse equation.
So
Say
you are typing an entire equation in the box.
yes.
Okay.
I have to give this is an input box where you have to give command. You have
Okay.
to just write equation, whatever written in the book or textbook.
Right.
You have to write the equation, and it will show you the graphics,
Okay.
right?
Right.
Say I'm writing here x square plus, oh sorry, x square divided by, say I'm writing here 64, equation of a ellipse,
Yeah.
plus y square divided by, say, 9 is equal to 1. So you can see this is equation of a ellipse, or you can change its thickness, or you can show the plot name also, whether it is ellipse or not.
Okay.
Uh,
But what if the equation is too big and it's not covering the whole graph?
it will cover. It will cover. You have to see actually it will cover anything. Otherwise, we do have this input box also.
Okay.
You can see whatever you are typing. If you are not able to type, you can insert from the this window. Here
Okay.
we have a constant. Here you have a function to input. You have a constant to input. Even you can add it your input. Suppose I want to add it, you can change here. Suppose I will write here 16,
Right.
say. So you can do this way. You can write here, say, 16.
Where did you
Uh,
get this window from, sir?
no, this is here in an input box.
Okay.
At the left of the input box, you can see that this is a small text equation editor is there.
Okay.
So from there you can change also. Now you can see the graph, right?
Yeah.
So means any change you will do here, you can see it, or you can assume what will is going to happen. But that you have to take care when you are typing in your input box. Actually, we all should go through the our textbook and what are the parameter or the functions given there. If you will type accordingly, definitely the graphics will look appealing and better, and it will helpful for the student that way. Otherwise, if you will keep on trial, and you will get confused in the initial stage. So this is the way we can do with the different kind of implicit plot. So implicit means, again I'm telling here, where you do have two variables x and y. So that way you can use this kind of creation in KmPlot.
Yeah.
Now I will take one more important feature of this plot, that is a polar plot. Okay. This polar one is a very beautiful one, and we can do lot of things by using this polar plot. Say polar means like equation of a circle in a form of sine theta or cos theta. That is a polar equation. Say suppose I am writing here a polar equation. Say I have a radius r is equal to, say I am writing here 8. So if I will do this, I will enter. So I have a circle of radius 8. Okay.
Right.
Or if it is not visible, I can make it a small, let's say 6. So now it is a little bit small. If you want to, again the same thing, if you want to increase thickness, we can increase. If you want name, so we can name it. So it's showing the radius of 6. That circle is here. Okay. You keep on changing the radius, you will have the different circle.
Yeah.
Even you have a plot range also here. If you see in the left side, there is a plot range. Here it is 0 to 2 pi. The circle covers 0 to 2 pi. Suppose I write here only pi, then I will go to the insert equation, and I am just inserting pi here and then close. So if you see, this is the half circle. Okay, means 0 to pi is showing only half circle.
Right.
If I will write here complete 2 pi, then it will be a complete circle. If I am writing here 0 to pi is a semicircle. If I will type it pi by 2, say, so it is one quadrant of the circle.
Okay.
So this way you can change the parameter, and you can see the graphics how it looks like. Same thing, even if you want to create something new, then you can also do that one.
Okay.
Like I'm creating for sine cosine function, how sine cosine will looks like in a polar form. Say I'm writing here anything. Say I'm writing here. any equation, say R A for any variable
Okay.
is equal to, say, suppose I'm writing here sine A.
Hmm.
Okay. So I have this small circle here, means R is equal to sine A. It
Right.
is the equation of a circle, right?
Okay.
So this is showing sine is itself a circular function.
So can you
Okay.
again increase the thickness of this circle?
Yes, that I will increase. I will show you. Now this is a very interesting here. When you will change the feature of this. Suppose I will write here, say it is for sine A.
Okay.
I want to increase angle, say it is 2A.
Right.
Just giving it 2A, then you see how it just looks like a butterfly. Can you see?
Yeah. Yes, sir.
So this way you can see the feature. If you increase continuously the value of this angle, say I'm writing here 7A, so you can see. Okay, so the flower type or things are coming.
Yeah.
If we will change this function, suppose I am changing this function, or I will reverse it. So that time, say if I will write here f of A or R of A, that depends on you what kind of input you are giving. Suppose I am writing minus, now I am reversing the angle, then let's 7 sine, or say I am writing same thing here 7 A. That time you can see, now you can see the graph. Okay,
Yeah.
now it's changed, means one is you have taken for plus sine A and another one is for minus sine A. Then you
Okay.
can see how it's changing, how it looks like a flower.
Yeah.
Okay. Same thing we can do with other function also. If you want for cos, you can just change here cos. If you will change it as cos, so how it will looks like, you can see for the cos value, it's little bit change. Same thing you can do for this one also. You write here for cos, for second one, for this also cos. Now see, now why it is coming the same, then it can create curiosity in a student. They feel the sine and cosine are different, but in a circular function their behavior is very similar, because it's in between the 0 or 2 pi, or you can say it is in between 0 and 1, so it is a cyclic. So you will not, or anybody will not find the difference. So even teacher can give a different kind of question, and he can evaluate the student by changing these function and ask the question in different way, right?
Okay.
Same thing, suppose I'm writing here for, say I will write for another function 10A. Okay, so suppose it is 10A.
Right.
Now see, so how it looks like. Now you can see the graph, how it changed.
Yeah.
Because tangent is a little bit asymptotic function. It goes up to the infinite end.
Right.
So the graph is open, right? So you can see the graph is open here. So this graph is again, if you want to change it for another one, say I am writing here it for cot. Okay, cot. Say suppose I am changing angle cot. Now see, this is inverse of 10. Okay.
Okay.
So means this way you can see the pattern of the input function, and you can see how the graphics is changing when you are changing angle.
Yeah.
This way, even if you want to increase angle here, then you can increase this angle also. Say I'm writing here cot A, we can change the value, say I'm writing here 2. So you can see how it changed.
Okay.
Now the both sides is covering.
Yeah.
So both functions, tangent and cotangent, are behaving like this. When I'm writing 10A, it is in a vertical axis. When I'm writing it is in cot, it is again in a vertical axis.
Yes.
Sorry, horizontal axis.
Horizontal,
And
yes.
yes, and when I'm again making it cot 2A, it's going again to the vertical axis.
Right.
So that way you can see how that angle is changing. When angle is changing, the function behavior is changing. So even we can try something else also.
Okay.
I am just unhiding it. This option is here, and I will show you some more beautiful feature of this polar function here.
Okay.
Say I am writing a equation here. Say f of A. That is very easy. You have to just type the equation and then you can see the changes.
Okay.
Say I'm writing here 2 tan of a plus I'm writing some other function 2 sec a, say, right?
Right.
So you can see there is nothing is shown here in the window.
Yeah, it's
Okay.
blank.
Yes, so what it is showing here is showing now, because it is unhidden, so I had opened it, so you can see the tangent behavior and secant behavior here. If you see, can you see, or I have to increase thickness?
So we can see, but if you increase the thickness, it will be much pretty, much better visible.
Sure. So now it's visible. I think so.
Yes, sir, it is.
So this just I'm writing here 210a plus sec a at an input window, and you can see the graphics how it looks. Okay, and if you invert this function, if you change this one, say I'm just changing it. I'm just changing it by a slight sign. I'm writing it minus here. Okay.
Okay.
In place of plus, I'm writing minus, and then you can see the behavior of the graph. Okay, now it is in the reverse side.
Yeah, opposite.
Okay. So even you can combine both these also if you want to see the pattern how it looks. So you can also change this pattern. So here what you can write here, you can say suppose this graph earlier one is 210a 210a plus say 2 sec a. Okay.
Okay.
2 sec a. So is there any error? No. Okay. Just a minute. I will change this one. GA, because it's A. Okay. Only input I have to correct. Okay. Now you can see I will make thickness little bit more. Then you can see how beautiful things is there. Now can you see?
Yes, sir.
So means this way you can see the behavior of a different polar function. Even you can create for hyperbolic function,
Right.
or you can create for many things we can try. Right now, even if anybody interested, we can show it for hyperbolic function. For hyperbolic only, we have to type here h. Okay. Sine hyperbolic, cos hyperbolic, or sec hyperbolic. Now you see the graph. Okay.
Okay.
I just changed the nature or hyperbolic function, and you can see the pattern how it looks. So this is about the polar function, how we can create polar function. Now I will take something else, like we can take parametric function.
Okay.
The parametric plot is again it is of kind of two variable, and it's a very similar like of polar coordinate, but its feature are much better, right? Suppose I do have two variables here, x and y in left hand side, and I will change the value of x, right? So suppose I am writing here say sine of t, because I have a two variable here, t and k, and I am writing here for t. Okay, so this is sine t I had written here, and for the next suppose I am writing here cos t. Okay, so you have a again circle. Now you can see what this circle is. A little bit dark I have to. Now it's okay. Can you see it?
Yes, sir.
This is
a small circle in the middle.
Yes, it's a parametric plot, or you can see here we have a two variable, and I am combining sine t and cos t, and then we can see the values and how the graphs for these two values are. And here you can have a plot range, you can change the range, and then you have a different kind of features of this graph. Suppose I am writing here, say for pi by 2 up to, I want to go up to pi by 2, say, okay. So you can see one quadrant again.
Yeah.
Okay. So means this is also a very good feature here. Or you can also change the values, like suppose I am writing here 2 sine 2t as I was doing earlier. So you can see here how it will looks. You can see the function, say I am writing here. So you can say I'm changing the value and how the curve is changing, right?
Right.
For any constant, even we can make it like this also.
Okay.
Suppose I'm writing one more thing here. Say I'm writing here k, just a constant. I am putting a value k cos t. So the curve is gone from here, right?
Okay.
For that, what I have to do, for that I can do one thing here. I can list the k values, and then we can see how it's changing. Suppose I'm going in a list in the left hand side, and I will list means you have to just give different values of input, and then you can see the pattern of the graph. Say I'm writing here 1, 2, 3, 4, 5, say 6. These are the values I had written here, right?
Right.
Now you can see the pattern, how it's changing.
Okay.
Can you see?
Yes, sir.
Means,
yes, sir.
Means even you can see it using a slider also. By slider I will animate it, but that I will do later, little bit later.
Sir,
First I will try
yes.
to.
I can understand it's a big tool and there's a lot to know about it. Though you were explaining these graphs of maths, but I wanted to ask, can we use this same software KmPlot for physics and chemistry as well, because we've got graphs in physics as well. So can we use it, and if yes, then how can we do that?
Yes, why not? Why not? Let's. I will show you one example.
Sure, sir.
Then you will understand. Suppose I am taking polar coordinate. First I will delete all these, and then I will explain you how it is useful. Okay. Suppose I am writing here sine of x. Say I am writing here sine of x. Okay.
Yeah.
So this is a circle I have. I will just make it little bit dark. Then it will be visible. Okay. So this is a circle, say, and I'm just putting a constant value here. Say I am writing here k. Okay.
Yeah.
I'm writing k here, and I'm just changing the function, say, by 5, and then you put enter here. So here you cannot see anything here in the graphic window. But why it is so? So you have to change this k in input also. You have to give the value for the k. Okay.
Okay.
So I'm going to give the values for k here. Suppose I'm going to give the values for k here. So I have to again list out. Say I will write here 1, 2, 3, 4, 5, 6, 9, or any value you can put, right? So I put these values. Okay. Now you can see the graph. Now I am using here a slider, right?
Right.
So that I can see the pattern, or I can animate this one. For that I have to go to the show slider. I am here now in a show slider. Can you see it?
Yes, sir.
I'm using here slider 1, say. So if I will move this slider, you can see what is happening. Okay. So means this way you can see the behavior of the graph. Here you can say, suppose I'm changing value -5 to say plus 10. Okay.
Okay.
So that way, if you see, you can see the values. Okay.
Okay.
Number of values increasing. Now you go for the animation. You just select the cross here at the graph, and then animate the plot. Okay.
Okay.
So suppose I will animate the plot. So how it will looks. You can see here the plot, how it will appear. So can you see?
Yes, sir.
Okay. So this you can see. This plot, this graph is animating. So you can minimize the value, or you can increase the steps. Then you can see, right?
Okay.
Can you see?
Yes, sir. It's moving.
Okay. It's moving, means it will animate in many things we can do, like I can show you what are the beautiful feature of this one. Say, can you see this image? Can you see this image?
No, sir. I can't. Yes. Now I can. Yes.
You can see. So this is the creation of this KmPlot.
Can
Even
you maximize it?
yes, I can maximize it. So can you see it? Okay.
Yes, sir.
So this way, even you can see this. All this has been done using KmPlot. Now the
Okay.
question is, you are talking how it is useful for sciences and for physics and chemistry.
Right.
In physics, we are teaching, say, we are teaching a student about the AC, alternating current,
Hmm.
right?
Right.
So when we are teaching alternating current, we are telling them that AC is a sine wave. We usually say like that,
Yeah.
right? So suppose we are saying it's a sine wave. So sine wave means its nature is sinusoidal. So the electric current which usually we see at a home, that is actually a sine wave, or its behavior is just like a electromagnetic wave,
Okay.
right?
Right.
So if we will animate this, the behavior, they can see what is the frequency of the sine wave, or what is the frequency of AC wave. They can find out the peak value. They can find out the RMS value of AC current by using it, by using phasor diagram for it. We can beautifully explain physics. I already did lot of things even for SWAYAM portal, where I had given lot of animation using GeoGebra and KmPlot
Okay.
to teach physics for the student. And even I used it in chemistry when you are teaching about packing fraction of
Okay.
a solid, when you are talking about binding energy. Even in medical sciences, RM plotter is very much useful to see the ECG, electrocardiogram.
Okay.
These all features are there. You have to just be careful about the input. Means when you will give the frequency of heartbeat, it should be 72 per minute. That way, if you give it and then you match the ECG with the graphics or KmPlot, then you can see how similar the pattern is and
Okay.
where the
Okay.
malfunctioning is going. Means even doctor are using KmPlotters. The same thing is there in their tools or their instrument.
Sure, sir.
These all are
Okay.
animated graphics, live graphics.
Okay.
So we can use beautifully this KmPlotter and even
Sir,
I think.
we don't have much time left,
Okay,
so
okay, okay. No
and
problem.
there are some questions which I wanted to ask. Sir, is this software compatible with Android and iOS as well?
No, ma'am. Actually, right now, in Windows Live you can use it, but iOS I haven't seen is not compatible.
Okay.
Even in Mac or iOS I haven't seen, but in Linux it is very much compatible, as very much a powerful tool for the
Okay.
phasor representation, for the graphical representation.
Okay.
Yes,
All
ma'am.
right. Then, sir, so you have talked about doctors using KmPlot for checking the ECG and all. What about the teachers, the evaluators?
Ah.
Can they use KmPlot for
Yes, yes.
evaluations?
It's very simple. As I told you, suppose if you are seeing the window, I have to export this graph in different form, right? So
Okay.
if you will export this graph and then attach this graph to the Google form, or in any analysis, or even for the quiz or for anything, when you attach this and then you can make a question based on the graph. Even you can give animated graph to them. When they will visualize, you can ask them a question: what is the frequency, what is the amplitude of the wave, and at what point the wavelength is minimum, at what point the frequency is maximum, and what is the maximum height of the peak. Like I'm saying, we can find the maximum or minimum of the curve. Suppose the beat is going up to say 333 bit, right? So
Yeah.
it will be very louder, so we can decrease it up to 120 dB. So that way teacher can ask question from the student, and these graphics, when he will visualize the graph, he will be more comfortable to answer, right? Or even in statics, like we usually ask the question, the same way we can evaluate our student. Even we can use it online, we can share it anywhere.
Okay.
Then we can ask questions based on it. I mean,
Okay.
variety of questions we can ask.
Sure, sir. Okay.
Yeah.
Thank you so much for joining this webinar with us. And this information was really useful for all those maths and science students, especially who can download the software and can learn the graphics of maths very easily. Thank you so much, sir.
Thank you very much, ma'am. Thank you very much.
Thank you to all the viewers as well. You saw this session and you commented as well that the sir has given some nice presentation. Thank you for all the comments. And stay with us. Don't go anywhere, because we are coming back with another special program of ours, Sayog. The topic is going to be planning for one's own future. So stay with us. Don't go anywhere. We are coming back in a short while. Stay healthy. Stay happy. Namaste.